All right. Well, thank you for the invitation. I think this might be a bit loud, but anyway, you tell me if it is too loud. I'm a bit of an outsider, perhaps, to this community, but I feel very close at the same time. So I'm a scientist, in many times enabled by the data that you produce, and in many times also trying to work in a similar space to the sort of analysis that you generate, but with a slightly different research questions. So I hope that we can have a really interesting conversation here, and I hope I can share some stuff with you that might be kind of mutual interest. So the title of this talk is From Counting to Connecting, and I see it as an exploration of academia as a complex socio-technical system of information transformation. So the idea is how we see through the lenses of data, academia and universities as a system, and how we discover things that are interesting for librarians and for the general public and for management. So a bit of background. I will go through a very short intro, so you have a bit of understanding of why I am here and how is it I got here, and why this might be relevant for you. And then I will focus on one application project, which we call the knowledge landscape, and is this data-driven, interactive, and visual exploration of network landscapes, knowledge landscapes. And then perhaps, if we have time, net sites, but I will try to focus as much time as possible for questions and answers. And well, my background, I finished my PhD a couple of years ago, and I focus on how we see networks, and in particular networks of what we produce, what we do, and who we connect with as a mechanism to understand how systems work, okay? And I come from a group that is engineering systems group. So we try to think about reality in terms of these big engineering systems. In that context, I have produced a few papers and things in particular. This chapter might be interesting when you work with network analysis. It might help you trying to think which sort of possibilities you have when you analyze data that is relational in nature. And now I will jump more specifically to the project that I call the knowledge landscape. Both are in the logic of the meta project that we call NetSites, which is obtaining network insights through data. But that's that. So if we think as DTU, the place where we are, as a complex engineering system, we can think about it as this socio-technical process of information transformation. We have data input, so as researchers, we use other papers, we use other researchers to transform that into something else, into other papers, into other projects. So if we want to understand this place, we need to understand how we go about transforming data, how we go about transforming information into knowledge in education, in innovation, scientific advice, and all that. And so I try to sell this internally, in fact, and that's how I got to do it. I got to sell it to the office that now holds the library inside of DTU, but also all the innovation and sector development services. So I sold it, quote unquote, because I'm a researcher, so I needed to convince them to do it. Essentially, that's the deal, right? And why and how this might be relevant for you? On the one hand, you're already more than aware that we have so many more possibilities for descriptive and prescriptive analysis. So we have data and we have dashboards, and all that is great. But that means that we have new possibilities, new expectations, and new goals. So that sets a bar that is a bit higher in some regards. And then it means that we also have new levels of analysis. So while for a long time it was very important to have the granular data totally clear, and then whoever does with that other sort of analysis at other levels, it doesn't matter. But there are other sort of analysis at the meso level that we can call meso level, in the sense that you don't need to have a specific clarity about one researcher and their production, but it might be kind of a group that is a bit more fussy, and you might not have perfect data. But it's still interesting to find out what we can learn, and there are other kind of questions that emerge at these different levels of data that in many cases might be fuzzy. We might have imperfect data. Then another reason why I think this might be interesting is because I will use Tableau, which you will learn on Friday. So you will have kind of an idea of what can be done. And then finally, I participated in last year DST4L. So I also got kind of an understanding of which sort of elements might be interesting for you. So I will try to share that. And to start, it's this idea of, my passion at least, is to go from counting. This idea of we do census, we just have all the information in nice little stocks and piles. How we go from this to connecting? Because things happen here. I mean, of course, we need that because we need a census. But the mechanisms lie in the connection. So how we build this picture. For ages, we were not able to handle this other level of analysis because it's much more complex. It's inherently complex. But now we can. So let's play with that. And one way of visualize this is we have, for example, the knowledge census. So this is data that you are probably very used to see. All these pies with data that are really interesting to see how much you produce and when you produce it and so on. And we have, of course, infrastructure and all that is also very important. But we want to move into this knowledge landscape, how we produce what we produce. And if we want to put it in terms of an analogy, we have tables, and we do a lot of those in reports, and they are great, they help. But then we can go a bit more in terms of insights, and we might want to graph these things into a way that we identify outliers, and we might get some better insights. That's better. But then we can move in a direction that is a bit more interesting, I will argue, which is where these things are placed in a knowledge landscape. Okay, and I will explore what this means, so don't worry. It's not just the image and then it will disappear and never be mentioned again. So we're in this journey. And I will try to show you how you can go into this journey without learning all sort of complex code, essentially. And one way of thinking about this, because let's be as concrete as possible, why will we go in this direction anyway? So one way of seeing it is, okay, what can we learn in addition to what we already know? So DTU, an engineering university, usually benchmark itself against some of the best engineering universities in the world. You want to reach that level, and let's compare it with MIT. And we will say, well, perhaps it's just a matter of scale. We put more money, we buy researchers in, and we put more infrastructure, and we have an MIT. Is that correct? Let's find out. So we have this picture, and then we have MIT picture. And I can go back and forth, and I can say, yes, scale. You have more citations, you have more publications, you have more money, somehow linear relationship, perhaps is scale, perhaps is money. Let's see. Then you have University of Copenhagen, very different picture, very different disciplines, perhaps hard to benchmark again. So then we will say, well, it's just that the composition is different, so they are not comparable. And that's one way of seeing it. So far, only counting. My question is, what happens with connecting? What can we learn from connecting? And here I did an exercise that is super simple, is zero sophistication. I just pick up as many publications as I could, I think, in a way that was fast enough. I think it was the last 25,000 publications, and I knew the journal in which a publication was, and I knew the person that published in that journal. And whenever somebody was able to publish in more than one journal, it was creating a link between two communities of knowledge, right? And the more we have of that, the more we can see that different areas of knowledge are connected within a university. So for DTU, it looks a bit like this. I will not go in detail, but essentially, we have one area that is very bio, and one area, or how we say it here, wet labs. And we have an area that is very kind of physics, mathematics, or you can describe it as dry labs. And this is what describes a bit the macro communities of knowledge in DTU. Okay? The question is, does MIT look like that? Because they have the same areas, essentially. So does it? It does not. It looks like a mega interconnected supernova of a kind. You just have an explosion of areas of knowledge. Very little silos. there is a different philosophy, there is a different way of connecting areas of knowledge. And this is super naive analysis, whatever you want to say, but it is saying something. So this was the inspiration of, okay, should we look into this in detail? And then we can see Copenhagen University, total different ecosystem, and there are some interesting things even within the physical sciences, and you can go in detail into that. I won't go now. So what we did was to assemble this kind of dashboard to understand the knowledge landscape within DTU. So we wanted to go a step closer, learn a bit more. And we started with the very basic stuff. We have DTU Orbit, which is essentially a pure system, right? And I just talk my way through into getting somebody to give me the data in an export that was essentially a CSV file, as simple as that. And I had somebody participate in projects, somebody is an author of publications, and somebody takes part in activities. And I just use that data, relatively simple. But what I wanted to find out was this. How is that different departments connect? How is that these entities that are the outputs of a researcher connect and create this knowledge landscape, right? So this was essentially what I tried to do. And this is the amount of data that I put in. It's not complete, it's not perfect, but I will argue that at these levels and for these purposes, perfection is not the point. We are not trying to generate a report for each researcher saying, this is your perfect profile. I want to have an idea of the landscape. And it will be better than asking around with a survey, so fair enough. And this is how it looks, DTU knowledge landscape. So it looks like a pretty picture, and it's not so detailed here in the screen, but more or less that's the scale. So you have an idea of how many things we have happening in this network. And you can already see communities, the colors show communities and all that. All right, so again, this kind of part of the scale. And then I put all this into Tableau. Tableau is terrible with networks, it doesn't understand networks. They have nothing inside that has networks as an entity. But I was thinking, this is a landscape. So I will use the capabilities of maps. I will just use this as a geographical landscape where I have dots that are closer or further apart from each other, and then I will play with Tableau. So I did that. I used a traditional network analysis software, super straightforward, open source, Gephi, and I exported the kind of picture behind and the coordinates, and then I put it back together here. And what you see is that here I have all the departments in DTU, and departments and areas. I mean, they are centers as well. And they have colors, and then you have all these activities, person, publication I can filter, and I will show you live in a second. The nice thing is that then we can test certain things. So is DTU divided into zones, dry labs and wet labs, or not? And we saw kind of before very simplistically, but let's see if it is so much like that with a much more granular detail. So now we have, I highlighted photonic, compute, nanotech, energy, transport, dry labs, let's call them like that. One side of the graph. Wet labs, the other side of the lab, the graph, right? And with aqua being very wet and also over there in an island. So it's kind of interesting metaphor of reality. So that was interesting, but can we see a bit more? So there are other things like, can we characterize departments as, I call them distributed versus focused departments. Distributed because they connect with many, they have loads of tentacles around, and these are the departments that seem to have these characteristics. Compute, for example, can work with everyone. Chemistry is also very flexible, so they connect in different projects and publications, but then there are other departments that are much more specialized. For example, photonic, much more self-centered, more specialized, more focused. It's not bad, it's just how you transform knowledge. And then can we look into the effect of geography? Can we look into where we place the different buildings and if that matters or not for knowledge transformation? And because Tableau has all these capabilities, you can integrate everything in one go. And effectively, yes, we have kind of in DTU some buildings scattered around Denmark. And even within the campus, we have some distribution, so this might affect. And indeed, if I get kind of an average of the position of each department as a whole entity, I can see that the departments that are further away happen to be further away in this kind of knowledge landscape. So it seems to have at least a correlation. I'm not saying causation, but it's interesting, and it's also related with the history of the university and how things merge in gradually over time. And then I will show you this in more detail afterwards, but once we have data of a network kind, we can plot it as a network, but networks are difficult to interpret. But they can provide you with data points that are based on a characterization of the network, okay? So you can calculate things like centrality or information centrality, between the centrality, a number of measures that are interesting. And here, what I did was to put just the number of connections of each person in the department against between the centrality, which is kind of how much of a bridge you are between different areas of knowledge. And you can see there is a positive relationship. It makes sense. But some people are very good bridges despite of their connections. And some people are the opposite. Some people produce a lot, but much more in smaller groups. Okay? So that kind of gives you some ideas. And then for mental sanity, does this make sense at all? And one way of checking is, let's put all the different positions in the university and see if a network measure that is eigenvector centrality that measures overall influence in a system can characterize the different positions. And I just made the positions to be ordered based on the average of eigenvector centrality. And indeed, a professor is way more than a laboratory technician, and the order is almost the perfect order that you expect. However, there are lots of outliers, and we can learn a lot from those outliers. There are some PhDs that are way higher than a professor in eigenvector centrality. Yeah. So that's interesting. And then, can we learn about these specific areas of knowledge? Yeah, of course we can, and we can map things that are a bit more specific. Something that I did was to look into, for example, diabetes within the system. What do we have in DTU about diabetes? DTU is doesn't have a medical school, so we do things related with diabetes in more kind of engineering perspective, if you want. And yeah, when I type the word diabetes, I plot it in the graph. It shows me different areas that have stuff related with diabetes where the keyword emerges, right? It pops. Some obvious, like food, system biology. Some not so obvious, photonics, electrical engineering. What happens there? That's interesting. So we can see that is interesting because it's plotting a knowledge landscape. If you search in DTU, find it, it will be hard because you have thousands of records. And they are not ordered by any of these parameters. So now you can see, okay, the interesting bits, electrical engineering, we have these heel paths that had to do with measuring electricity, but then, of course, for diabetes patients, that's interesting. In photonics, glucose sensors, in physics, at the level of the wave simulation of particles. So that's interesting, and that can help us to learn stuff. And same thing with climate change. We have climate change expertise scattered in certain areas of the graph, and if we want to connect different departments, there are some departments that are easier to connect, where interdisciplinary projects are easier or more difficult. So we can learn about that as well. And then we can zoom in and say, well, in this intersection, who is there? How can we leverage that? And then you can see the different people, and then you say, oh, there are two postdocs that are relatively close from a knowledge perspective, but have not worked together. And as postdoc might be a bit more flexible. Should we use them? Should we connect them? That's one thing. And the question is, has this been used at all? Is it somehow interested for somebody else than myself? Well, at least it has kind of developed some interest within DTU. So heads of department in all those areas in DTU already expressed interest. So that's positive response for something that was cell bottom up. So that's good, but also outside. So outside DTU, there's also some traction. It's kind of an interesting way of looking at this data that otherwise is not used in this particular form. Okay? Now, one key lesson for myself is this effective decision-making support? And I get that question every now and then, and I will say, only when it supports what you already believed in, which is unfortunate, but it's better than nothing. So we need to work more on that. We need to work more in believing data understanding data, and even correct our own beliefs based on data. That's very important, because if it only justifies what we already want to believe in, okay, it's helpful, but only when we're in an argument with somebody else. I will show you very quickly the actual software and how it looks like in the dashboard that I created. So essentially, it's the same you saw before. Here you have all the different data points, and I can filter only people, let's say. Now I see only people, and I can look into an area in the graph to see what I can find, and the size of the people. In this case, it can be, for example, the between the centrality of how much they produce, so that can help in that way. I could also highlight kind of a region. This is all kind of a hack of Tableau. You're not supposed to do this, at least not in the original conception of that. But I can just look into an area of the graph, look at who pops up, and use that for very quick analysis that are easier, I will argue, that doing this in a table, if at all possible on a table, right? So that's one thing, and then I can filter as well based on how many connections people have, so perhaps I only want to see the top or not people, things of that kind. And I can think, well, the simplified knowledge landscape, how can we use that in any interesting way? Well, I forgot to mention here, you can very quickly input queries. I don't know, water. Where is water mentioned the most? Will it be in the wet labs or in the dry labs? And effectively, water is mentioned more in the wet labs. Things of that kind. Then, yeah, here you can play with this kind of simplification. You can also use this geographical landscape, if internet connects, yes, to look into these details. And what I wanted to show you is an interesting kind of example of what happens when you play around with this data and the sort of conclusions you can take. So I will go only to photonic, and I came across this just coincidence. And I will look only people in photonic, and I will keep only that so that it's easier to see. Same graph that we saw before. And I was looking at these outliers, and yeah, it's interesting. So this person produces a lot, but in the analysis it doesn't connect so much. And I don't know anybody. I mean, I'm one researcher into one department. So for me, photonic is kind of a black box. But I came across one name that I knew, which happened to be our rector, our current rector. And this data comes before he became a rector. So yeah, what can we learn? So the rector is an outlier in terms of publications in the negative sense. Should we fire him, or should he never be allowed to be a rector? So if you are totally KPIs blind, you should fire everyone in this region if your KPI is production. However, part of the reason of being in that region might be that they are connectors, and there is a trade-off between connecting areas of knowledge and producing stuff. So sometimes you just might not even have that trade-off. It might be just you are pouring on all variables. But sometimes you have these elements in the ecosystem that cannot be explained by traditional KPIs. And therefore, we should look into these sort of KPIs as well. And I will argue, in fact, that they are not KPIs in the traditional sense. So KPIs, key performance indicator, right? I will say we need to move into key performance predictors. And because before something happens, you need certain things. You need to act in certain ways. You need to do certain things. And then you can play a lot with different of these outlier boxes and all that. So that's that. And very quickly, I will show you how is that this can be ported into other applications that kind of intersect with other domains. But it's interesting to compare, I believe. So I apply the same logic into the industry, plotting companies, and trying to look for how to identify the right partner in the industry, in particular in the context of sustainability and clean tech industry. And there, variables that might be also very useful for researchers appear as interesting in industry. So we have technological closeness, which I measure based on text similarity, and categories, both things very common in bibliographic analysis. Relational closeness, people that work together, again, same thing, as in academia, geographical closeness, if we're close enough or not, and trying to make a model with this and predict who should meet who, right? And then we have all sort of variables that interfere in the middle, but we want to get this picture, right? And then what I did was to put together over 500 companies in the clean tech industry in Denmark and see how is that this generate a landscape as well that enables or not certain innovations in certain areas. So this is how it looks, that landscape. And why I want to show you this is in part because what happened was that this knowledge landscape that I showed you before was the trigger for this, and it showed also limitations. So Tableau can do certain things, but it's not great with networks. So I will show you, you can use that in a way for prototyping, and then you can see stuff even further and more customized. But I will never jump to a customized analysis right away because it's very costly and it doesn't make sense. But what we generated was something that was a bit more aware of the network structure, where you can essentially play around with the connections, understand what is around a certain company in this case, and more actively draw connections that, of course, Tableau cannot make because it doesn't understand the network and it cannot generate network metrics. You need to generate them previously. So that's a bit what I wanted to show you very quickly, and I think now it's better just to open the floor for questions. And in my mind, these are things that are more interesting, perhaps, in terms of potential next steps and collaborations in this space. So, of course, there are loads of analysis that can be done at EU and national science funding level. There is other sort of knowledge landscapes implemented elsewhere, looking into KPIs with other eyes, and see trends through content and structure. So if we want to see what is the next area of research that will open up, you can play with these things. And I know Vivo project is one of the things that also are advancing in this space. And for me as a researcher, it's a very exciting moment to be looking into these things because we are enabled by open data, we're enabled by a lot of tools, and we finally can play around with them. So thank you, and I open for questions.
Yeah, again, not so much a question, but a comment. But where were you 2 years ago when my college merged with another? We spent a year and a half with the faculties arguing about how several faculties on 8 campuses were going to be merged into 4 faculties. And we could have absolutely used that map that you showed of the interconnectedness and who works with what. So that, I hope we are going to see, look at how to do that a little bit later, because that would have been so useful. And now to go to the faculty, because like I said, they just argued and nobody was ever happy. They just sort of picked, well, that sounds like they might work good together.
Oh, yeah.
And they don't yet. So yeah, hopefully we can see something like that. That would absolutely be useful in so many ways. Yeah. And going forward, continuing our merger and continuing to form faculties.
That's a super good point, and actually it reminded me a story that I wanted to show you, and you helped me to introduce it in a way. So we had a similar situation. I started this thing, I don't know now, a couple of years ago, I don't even remember. By then I didn't know anything about DTU transport, any situation, I had no idea. I just plotted data, I just analyzed and interpreted on my own without feedback from management, not really. But I knew that there was something going on that was strange in DTU transport. From the point of view of data alone. They were here, very isolated, but they were one of the very few departments with these characteristics that were on campus. So they were on campus, but they looked like off campus. So that didn't make sense. And then I just let it go, it's not my business. But 1 year after that, after we published this, and this didn't influence it at all, the decision, DTU Transport, there is a big kind of crisis sort of thing, and is merged with DTU Management. And I was like, okay, this is interesting, because DTU Management, in my analysis, appeared next to it. And in fact, Transport appeared like an appendix of DTU Management in the data. So it was kind of anticipated something that has a political nature. And part of my reflection as well is, even if this had been there, this won't have affected in one direction or another. Perhaps it will have made it easier to argue, because the reasons for these things happen to be political most of the time. So even if you have the data, you will use it only if it confirms your beliefs and your interests. So it might speed up things, but I'm not sure we are at the stage where it totally transforms a decision, because we're not prepared to interpret data so much, and we are used to believe in tables and KPIs. We don't understand necessarily this, and we don't necessarily want to use it actively because it transforms a political system. And there are interests against transforming political systems. So yeah, very good point, thanks.
Okay, yes. Right. Oh, sorry.
No,
okay. I was, when you were looking at the thing with two postdocs that weren't working together, but they were very close in the knowledge landscape, that kind of made me think of course, to a heritage area, something like Ancestry and some of the other big genealogy websites, where that's also a network of people, and where you keep getting sort of updates sometimes. Are you maybe related to this person? Because that, becomes new information keeps coming into it. And I was thinking, would it be possible to use something like this in a more, for individual researchers, so that this sort of data and this network would be something that I personally could use as a researcher to find others who are perhaps doing things related to me that I have no, because right now I have networking and a lot of serendipity to help me along trying to find other people who are interested in the same things that I'm interested in. But would this be something that maybe one day in the future could help researchers find other people who are doing related
Yeah,
things?
definitely. And this is what we try to do for industry, right? So if I am selling bioenergy, the idea is that depending on the factors that I select, so if location matters more, I just reshuffle the network to reflect that location matters more. And I will get recommendation based on location more, or if the text of our companies matches more. So kind of that's the idea. We're heading into that direction, and of course there are other things in this space, and I think that it will be normal in a few years' time that will happen, right? I mean, recommendation systems and recommendation engines are all over the place. My key argument as a researcher against how they are deployed now is that they are incredibly obscure. So Netflix tell me which movie to watch by a combination of things that they don't want to tell me because it's proprietary knowledge. And that's fine because it's a movie business, and that's fine. But if I want to work with another company, if I want to work with another researcher, I want to have fine understanding of why the recommendation is in that direction or not. I don't want just to be drawn into this direction or another because of whatever. So that's why we build this thing, for example, in a way that you select the parameters, you see things moving around, and it's up to you to change it and tweak it. So you have a recommendation engine that is based on your mental model of a situation. And I think that's the whole point. And I think we'll need to be very careful, for example, recommending papers and all that in these recommendation systems, how we make the engine transparent. Not only the data transparent, the algorithms needs to be somehow transparent. Sorry, you had a...
Yeah, but that was maybe some of the same thing, but because I think about what the space between the nuts, how long the spaces are between the lines, how the size of the lines between two nuts, what the size that, because that's quite important, because when you interpret it, you're putting things into a media. You have to understand how long, what the size,
Sure.
What the size the lines, the size of the lines.
That's, I think it's an important question, and it requires a clarification in terms of a network. Okay, so a network is a two-dimensional object that is trying to represent a multidimensional space. So just like a map, a 2D map of the world is distorting reality, a network distorts reality. because otherwise you will have n-dimensional objects that are way too difficult to comprehend. So the visual representation is only an aid for interpretation, and you can have certain rules and you kind of optimize the space. Usually it's not bad. Usually it's not bad. But then what you need to do is to quantify this through other measures. So then you go back from visual to quantitative numbers. And there is where you can say, well, in terms of betweenness centrality, there is a measure that measures that beyond visualization problems. But it's good to have in mind, like you only use it as an object that aids understanding. But it's not like a graph of a plot, a two-dimensional plot. It is a different object.
What I'm kind of seeing is, and this is from my own background in statistics, it looks like it's based on a form of non-metric dimensional scaling. It's sort of, is that what it is? It's an ordination, basically, of the relationships, the distances in sort of n-dimensional space?
Yeah.
Is that how you've, or is it?
Yeah, I mean, it's essentially just that the network analysis community kind of has its own ways of dealing with this, but it's essentially
basically
exactly
an NMBS.
that. Yeah. It's one way of, and there are many different layouts that deal with that differently. I mean, that have different rules, because also you need to space out elements, and there is almost an stylistic decision as well.
Right, exactly. But when you described it, it sounded exactly like what I do with my ecological work, non-metric dimensional scaling to find the relationships in communities. Yeah.
Yeah.
Okay, thanks.
Essentially.
Any more?
Yeah, I think this is really interesting stuff that you show, actually, based on, it's basically business intelligence that you do, and I think it relates much to also the title of your talk, From Counting to Connecting, and I think when we look at research and the kind of bibliometric analysis we do focused on research output, I think you actually what you're doing is that you're building new indicators for researchers and how they should be evaluated. I don't know if you're thinking of that. That's a question. And I think it would be interesting actually if this work that you do could be more appreciated in policies around evaluating research, because we do a lot of counting actually, and we don't do network insights into research. I mean that. Looking just with one of the slides you had as a KPI as production, and then have a KPP that looks at collaboration or a bridge, just that name bridging, it should be something that humanities, they do a lot. They don't produce that much, but they are really good connectors, and it's not part of the evaluation system at the moment. So some of those insights you get here are really crucial to get the management of universities to know about, I think. So
that's true, and I think my comment is essentially the connection that we have with KPIs is strong because whoever is up there because of the previous KPIs and the current KPIs. So the incentives to change KPIs are tricky. Unless they coincide and they give you the same result as the previous KPIs. So what I will say is, yes, to treat them a bit as KPPs, I prefer, so that you understand, okay, we of course want to publish more papers, but how we do it affects, especially in the medium and long term. So we can be an institution that has a very different soul depending on these other things. That's kind of my take.
So before we wrap up, because this is about practical things as well, I wonder, you showed Tableau, and I've heard from researchers that they want to understand their communities in these ways, but it's the difficulty of learning something like Gephi to visualize networks. I wondered if you knew of some easier steps you can take to visualize your network if you have some of this.
And it's super simple, in fact. I mean, I am not a good coder. I am terrible. So you can take me as an example of somebody that really hates to code. I'm not a developer. I just use things that are out there, and I try to make something creative with them, essentially. So SciencePo in France. They have a team, I think they call it Media Lab, a bit confusing with the MIT, but anyway. And they have all sort of tools that you pick up a CSV file from, usually from Web of Science or Scopus, but you could use it in the same structure as your library, and it spits out a file that you open in Gephi and Data Network. You have zero code, zero. And you need to learn a little bit of Gephi. So I'm cheating, but you know, is how we get things done faster. Yeah.
Well, thank you. Is it Science Poll?
Science Poll, yeah.
Okay, so you have to check that out. So we're ready for lunch. I think we're wrapping up the questions, but thank you, Pedro, for your talk.